Welcome to coding. This session here is going to kind of get you started with some simple notions. It's not going to be the simplest code you'll see. If you go look online, the first thing most people will show you is just something that prints something out that says "Hello World," and there's a value in that. Making sure you have your environment set up and your code's compiling and runs and everything else like that. That's useful, but um, you know, I want to dive in slightly more than that. I just want to get you used to seeing useful applications, things that people actually might build at some level. And so, what's going to happen through this sequence is you're going to see in this video what a simple application looks like. And then in following videos, you're going to build the thing that you just saw. And that's perfectly okay. You need to mimic exactly what other people do to start with. Think of it this way. The first time you do a dance, the dance instructor doesn't say, make it up, go from there. They teach you moves. They teach you the ordering of the moves. They teach you something that will build the skills for you to be able to improvise later on, to be able to build your own dance, or in this case, you build your own code. So that's where we're going to start. If you have experience and can jump out further, then great. I'm not trying to hold you back, but this really is targeted at people who are just getting started, and it's going to be useful, hopefully, for everybody. But the expectation is the path I'm suggesting is going to be for the newest people. All right, so here's a simple application. Let's talk about the pieces of this real quick. So the very first thing you see at the top of this file is there's a helper. It's going to be called a function that calculates the BMI using empirical measures. So the BMI, actually, the formula for that is typically in kilograms and meters, but we're going to do it in inches and pounds here because I'm teaching this in America, and we are stubbornly used to empirical measures. Um, so that calculation is quite simple. It's 703 times how much you weigh in pounds divided by the number of inches of your height squared. So if you've never seen that formula, that's what that formula is. Ridiculously simple when you think about it. But the idea is that there's going to be that calculation. So it receives the information, the height in inches, it receives the weight in pounds, then it returns back you that BMI number. The next thing we see after that is our main program. This is another function that runs the input to go and get the height and weight, calls that, and then prints something out. We'll talk about those lines in a minute, but that's basically the function of what it does. So it's a lot like Hello World, just with a little bit of input as well. And then this last bit of code here is the actual call to call the main function. So the way Python works is we create a script. There's some functions defined. Those functions have to come before this call to main. Some languages doesn't care about the order as much. Python, at least the call to main has to be after it. I think you can switch around the functions inside of there to some degree, but generally speaking, a lot of languages require things to be seen up above them. Some other languages don't. It's actually a compiler issue, something you'll learn about more if you go into computer science full time. But it's worth talking about the flow of the code because, as I said, that very last call here, main, is where everything starts. And so the first thing that Python, when it runs this, finds is this call to main, and then it comes up to main and starts going down from there. So if you're reading a book, you start at the top of the page and you read down. Well, this is a little different than reading a book. Think of it this way. You flip the page in a book, you see a figure at the top of the page, you don't start looking at the figure. A table, you don't start looking at the table. You typically will skip by that and then read what's below it, and then you'll go to that table when it's referred to. I mean, if you read strictly speaking, sometimes it's those figures are so interesting you go and jump at them, but computers aren't interested. They do exactly what the rules say, and the rule says, okay, I start at the script after all these functions, and then I do exactly what you tell me. Hey, go do the main function. All right, so at that point, it asks, hey, what's your name? It says, what's your height? What's your weight? And then it makes the call to compute the BMI using the empirical measures. All right, and so this flow is what happens to the code. It jumps between each of the functions when they are called. The biggest thing to remember in source code is it only does exactly what you tell it to do. All right, so this is all theoretical. Let's see what it looks like in action simulated. We'll see what it looks like in action in a minute before. So here's the code again. We're going to watch it run. So again, once we get into that main function, this line of code pops up this prompt to the user, what's your name? And then it stays there until the user types something in and hits enter. So when I type in Tony and hit enter, then it goes to the next line. And so then the next line, it pops up instantly here, height in inches. And then it waits for my input. So I'm 6 foot tall, 72 inches, and then it kicks on down. And so then it asks for a prompt, weight in pounds. And then I can type that in. I think I'm about 195 pounds, plus or minus now, maybe around 2. I've been doing well this summer. And so once I hit enter, then the code continues on. At that point, it goes up and it calls this function, compute BMI, and it takes the two values that I received inside of there, and it sends those up. It gets the value back, and then it prints it out. So here, notice, it's not printing the whole name. It's just printing, in this case, this little notation is the first letter. We'll learn more about that as we go, of the first name. And it says your BMI is, and then we have to take the number that comes back and converts it back to a string. That's what this does right here. Again, we'll cover these things more later, but my BMI is 26.44. So I'm technically on the scale a little bit overweight, but not obese. 30 is obese, 25 is overweight. I like to think I'm muscular, but you can be the judge if you meet me someday in person. All right. So what we just did is a concept called tracing. Tracing is what we do when we track the execution of code in a combination of mentally and through notes. Some people can do it entirely in their head. Some people will take notes or use other visual cues like we just did on that slide before. We're going to do some tracing along the way as a way of learning the behavior of code. It's a good way to practice that. Experts, really good programmers, automatically trace often in their head just by looking at code, without spending much effort. There's still some effort involved, and sometimes we still write things down, but sometimes we just know what the code's going to do at a glance. That only comes with time and practice. It's not something that is a sign of intelligence so much as it's a sign of familiarity. You can put Java code in front of me, and I can trace it instantly with a great deal of complexity. Python, I have coded traditionally about once a year or so, depending on what classes I'm teaching or if I have a project that comes up in Python. I'm probably a little slower at tracing that. Like I probably have to stop and think a little bit. But there's some aspects of Python that are exactly like Java that I do very quickly. So don't think of it as a measure of how smart you are. Think of it as a measure of how practiced you are. All right. So another concept I want to talk about before we put this into action is the notion of variables. The code we looked at had 4 variables inside of it: name, height, weight, and BMI. And you can think of a variable kind of like this picture here, a shelf. It's a place you take a thing and store a thing there. So the name, in this case, is a bigger shelf than height, weight, or BMI. Height, weight, and BMI are just a number. A name could be many, many, many characters. So a number, if you look digitally, can be stored in a very small space, even very large numbers. A name requires 1 space per character, and so names tend to be bigger. So if I put my full name, Tony space Low, that's 9 characters that I'm storing outside of there, which is a bigger space required than height, weight, and BMI. But you don't have to worry about that. You don't have to worry about allocating space. The language will do that for you. But just understand that there is a difference in the way things are stored based off of the type of data that's being stored out there. And the variable itself is not the thing, it's the space where the thing is going to be. So the name could be Tony, but you could be running the program and it would be your name that gets put in that side of there. It's your height, your weight, and it would store your BMI appropriately. Inside of the code, we also had a few extra little helpers. We'll talk about these more as we go, but there was the print, which takes text and put out the screen. There was input, which receives input from the user, including some prompt to the user. And then there was eval, which takes text and turns it back into a number. Because when I type things into my keyboard, even though I'm typing numbers on my keyboard, they're not numbers until I treat them as such. My name could be Tony7, legally speaking, if I want it to be. 7 at that point is not necessarily a number. It's a character that went, into my name right there. And so that's something we'll learn more about as we go. But there's some little bit of helpers that you should be starting to attune to. And the last bit should be kind of familiar. We had some multiplication, division, something to a power. So when we did a square, star, star 2 was something squared. And then we also used the equal sign for assignment. So some of these things might be familiar, but note, it's not mathematical equality we're looking at. We're not saying is 2 equal to 7. We're not saying is height equal to 72, yes or no, or we're assigning that to be that. We're putting 72 on the shelf, if you will. And there's a slight difference in that. Again, we'll talk about that more as we go. You'll see about that in the readings. There's many ways to do that. But I wanted you to see a robust problem. And now we're going to build that robust problem and talk about each of these things as we use them. So at this point, just continue on to the next video, but get your development environment set up. Get ready to go off and get that set up. And there's a video to help you do that as well. So we're going to code in the next one. Whether you code along with me or code after you watch it one time is up to you. But get ready to code because that's going to be the next step of what we have going on.